Well, instead of graphing a system of equations and solving a system of equations like we did in the last couple sections, we're going to be solving a system of inequalities. To solve a system of inequalities, to solve systems of inequalities, we need to just basically graph each inequality. We graph the first inequality, and whether you use the idea of your slope and your y-intercept or the idea of making a t-chart is a personal preference. You can do whichever one you want. If it's y on one side by itself, you can use your inequality sign to decide if you shade above or below. If you graph this first one, you end up getting this red line. Since its y is greater than, you need to shade above it, so that would be here, where it's purple or where there's red. Graphing the second one is this dotted line, and since it's less than, you got a shade below where there's the blue or the purple. So you really have four regions over here. You have the white region, neither one of them work. You have the blue region, and that's only where the blue is true. You also have the red region, and that's where the blue or red is true. You also have the purple, and that's where the red works and the blue works. When you're typically solving a system of inequalities, you're looking at an and statement. Whether they give you the and statement or not doesn't make a difference. You're going to typically be looking for an and statement. Once again, that's the region over here where they both overlap. Where they both overlap, once again, is that purple region. In other words, your final graph really looks like this here. So in other words, your shading that you had from here and here, you would want to erase. Well, looking at this one here, when we graph this, y is greater than negative 2x minus 3. You'd start at a negative 3 because that's your y-intercept. Your slope is negative 2. So you go over 1, down 2, or down 2 over 1, down 2 over 1. It's greater than or equal to, so you know it's a solid line. Greater than, so that means you need to shade above. So you want to shade above up here in all of this. When you look at this right here, it goes back to the first lesson of this course for solving this. It's absolute value followed by a less than, so you could write it as one compound inequality. So you go your absolute value, or your x plus 2 less than your 1. You put another less than here, and then you go the opposite of what you had there. Then you want to go ahead and subtract a 2 from all three parts. Then you're really looking at graphing and shading everything between a negative 3 and a negative 1. Well, x being a negative 1 is a vertical line here at negative 1. X being negative 3 is a vertical line right here. But notice these are not equal to, so that's why these are dotted. And x is in between, so you're going to shade in between those two vertical dotted lines. Now, you'll notice I only shaded in between the two vertical dotted lines above the red graph because we're once again looking for where they overlap. So we had our shaded region here, everything above, and then only in between, and they only overlap in between above our red line. So let's take a look at graphing this one here. When we graph this one here, we know we have a slope of 1/2, a y-intercept of 2. That's really our blue that we have over here. Y-intercept of 2, up 1 over 2, up 1 over 2. And it's less than, so you shade below. Then we go ahead and we look at this one here. Y-intercept of 4, up 1 over 2 for your slope. And it's greater than, so that's this one up here. And it's an and statement, so you're looking at where these two overlap. Does the red region overlap with the blue region anywhere? The answer is no, so your answer for this one is the empty set. It has no solution since there's no place where they both overlap each other. So let's take a look at this one here. The first one, I'm going to go ahead and get y on one side by itself. Now I'm going to go ahead and divide both sides by negative. Remember to switch your inequality sign. So that's a y-intercept of 1, slope of 2, 1, rise over run, up 2 over 1, up 2 over 1, gives us this green line. Y is less than, so that means we need to shade underneath that. Looking at the next one, I'm going to go ahead and get y by itself, so I'll subtract an x. Now we have y-intercept of 4, slope of negative 1, down 1 over 1, down 1 over 1, down 1 over 1, and so on. And so y is less than, so you're going to be shading below. Now we have our next one down here, get y by itself. So you get negative 1/4 x plus 1. Y-intercept of 1, negative 1/4. So down 1 to the right 4, down 1 to the right 4. And its y is greater than that, so you need to shade above. Well, if you're shading above the blue, below the red, and below the green, they only overlap where we have our triangle. And if I can get that, they only overlap in the triangle. Let's also go ahead and figure out our corner points. We know they intersect here at 1, 3, intersect here at 0, 1, intersect here at 4, 0. Remember, when you're writing coordinates of a point, you need to have them as ordered pairs in parentheses.